Accepted.
Wow, that was cool. Hello, everybody. Thank you for choosing this talk called Tracing Issues in Your Application. I am super stressed because this is my first in-person presentation since my last one, which was like over 2 years ago. So, 2 words about me. My name is Marcin Grzejszczak. Since we're in Poland, you can pronounce my name, so you can find my Twitter handle. If you're from abroad, impossible, you can't do it. So go to my blog, toomuchcoding.com. I specifically set up this blog for you to have a link to my Twitter, so you can find the Twitter handle over there. Who am I? I work in the Spring Cloud team at VMware, working on Spring Cloud Contract, which is the framework for contract testing, and Spring Cloud Sleuth, which is a framework for distributed tracing. I also work with Micrometer, which is a framework used for metrics. So I wrote 2 books about testing. I have recorded quite a few video courses at O'Reilly, and the recent one is Java Microservices with Spring in 3 weeks. So now enough about me, let's talk about interesting stuff. So safe harbor statement. Let's leave it for like 2 seconds. Okay, we're done. So now, what we'll be doing today is some role-playing, because I will be acting as if I was a developer coding business logic. So for those who don't just know me, you might start to laugh because I haven't coded a business app for, I don't know, 8 years or so. Some say that even longer, that I have never written any business apps. I was also always into utilities and tools, but that's a lie. So let's say that today I am, in fact, writing business logic, and the business app that we'll have today is a tea brewing app. Actually, my friend and colleague, Jonathan Ivanov, who created this set of apps, says that you don't brew tea, you steep tea. So wherever you see today the word steep, that's actually brewing. Whatever. We're going to brew tea. So there's going to be a tea service, and we will call the water service via Eureka, so that's a service discovery mechanism. The water service itself has a database. And then there's going to be another call from the tea service to the tea leaf service. And the tea leaf service itself also has a database. So that's the whole architecture. Let's check out the code. Do you see, is the font good enough? Is it OK? OK. So what we have here is essentially the tea leaf service, the tea service, the tea leaf service, and the water service. Eureka. And that's pretty much it out of, let's say, interesting things. Now, today's presentation, the demo, of course, I will be using Java and, let's say, Spring-based tooling. But what I'm going to show you today is completely, let's say, technology and framework agnostic, right? The whole observability idea doesn't matter which language or framework you're using. But you need something under the hood. So in our case, we have something, let's say a dependency that we are adding for all the apps, which is Spring Boot Starter Actuator. By adding this dependency, we'll be adding Micrometer. Micrometer is a project that is used to capture metrics. And now, since it's embedded in Spring Boot, we will automatically capture certain metrics, right? But is it enough? Not really. We need to store these metrics somewhere, right? This is why we're going to have, since we have on the class path the Micrometer registry Prometheus dependency, that means that we will, via Spring Boot, have an endpoint that will take those metrics and represent them in the way that Prometheus understands. For those who don't know, Prometheus is essentially an application that can capture and visualize metrics. So having those 2 dependencies means that we are ready to aggregate and capture metrics. Now, so these are metrics. What about the case where we would like to measure latency in our system or correlate logs? For that, we need a different solution that will give us so-called distributed tracing. Distributed tracing. I'm going to go into more details later on, but I will just show you that things, you need to add something, you need to use certain libraries for observability to work. So in our case, I'm using two dependencies. One is Spring Cloud Starter Sleuth. For those who don't know, sleuth in English means a detective. I had no idea before I joined the project. So by adding this dependency, we automatically instrument quite a few libraries, and that way we are able to propagate so-called distributed context. I'm going to talk about that later. Also, we are instrumenting logs in such a way that the, let's call them the trace ID, the correlation identifier, will be attached to the logs. I will talk about that later on as well, but I just want to tell you at this point that certain setup needs to be made for observability to occur. Now, last but not least, let's say we've managed to capture metrics. We know how to propagate distributed tracing context. We know how to put the information in the logs. But if we want to visualize the latency, we need to push the tracing information somehow. We need to serialize it to some format and push it somewhere. So the format of our choosing is the Zipkin format, right? This is why this Spring Cloud Sleuth Zipkin dependency is required. So when we have the tracing information, I'm going to serialize it into a Zipkin format and send it out somewhere. I'm going to show you where in a second. OK, so this is all I wanted to show you in terms of the setup, because I don't want to go into big details, because they don't really matter. What matters is, for observability to work, you need to have certain libraries, certain tools that will help you out. Now, let's take a look at the app. It looks fantastic. Let me turn on the console over here. Oops. OK, then it should be bigger. So let's say we want to brew sencha that is small. We call steep it. And then underneath, we can see steeping time, amount of water. Fantastic. So we got it to 100. Fantastic. Let's pick Gurko, same thing, 200. Fabulous. Let's pick Dahong Pao. Amazing. That's great. Oh, I have a notification on my phone that the users are complaining that our system is not working fine. This is actually crazy because I've just clicked the system and it seems that it's working fine, right? I mean, OK, let's pick another one, like, oh, 500. Steeping time undefined. That's a bad value for a time. If we click here, we can see, yeah, indeed, it's like 500. What's there in the console? T-water is undefined. For sure, we're using JavaScript because the word undefined is there. We have internal server error. That doesn't sound good. That doesn't sound good. OK, we have metrics. We'll figure it out. We'll figure it out. So what I'm going to do first is I will go to, for today's presentation, as the observability visualization stack, I will be using the Grafana tooling. So right now, Grafana is an app that is used to visualize certain data sources, one of which is Prometheus. So what I want to do first, since I'm the only developer here on call for this particular app, I want to double check whether it was just me clicking some stuff, or is it like a more global problem that we can see? So what I will do is I will query the metrics from the T service, which is the edge service, whether there's a lot of those exceptions or not. So let us do it. I will pick the HTTP server request seconds count for the application called T service. And I will pick only those metrics that are not equal to none, because when there are no exceptions, then the exception tag would be none. OK, so let's pick the last 15 minutes. So right now, I picked the count, so we can see clearly that we have an increased counter for exceptions. Let's do a rate, because rate is, let's say, more interesting. So how does it change in time? So we can see that for the T-service application, for the URI T name, we have an increasing number, like the rate is above 0, which means that we have more and more exceptions from the API. Fair enough, so this is not a single case scenario, okay? So now, I would like to, let's say, visualize the flow of the request in our system for all the applications to try to reason about what is going on, right? So to do that, I will go to a different app, which is called Tempo. So we had, we have Grafana. We're all the time in Grafana. We had metrics from Prometheus. Now Tempo is an app that is used to visualize latency, to visualize the distributed tracing information. Now, Tempo can connect, so distributed tracing often connects with logging, because in the logs, you also have distributed tracing information. So what we can do is we can say, let's check our logs from the T-service application with error level, and show me the logs. OK, we have quite a few of those logs, so they are taken from all the applications, sorry, they're taken from the T-service application, all the, or a subset of logs that has the error level. So now, there is this trace ID value over here. So whenever a request comes in, an identifier is set, let's call it correlation ID, in this case it's called trace ID, and all the logs corresponding to that particular business operation, regardless of in which service this log takes place, will have the same value. So what I can do is I can say, OK, show me the trace view for this particular ID. OK, what do we see here? I can see that the T-service got a request. It took around 24 milliseconds to process the whole request and get back the response. Now, if I click this, I can see that the overall time was 24 seconds, and there is some additional metadata that I can reason about. So let's scroll down, and I can see that there was an error, 404, when calling the tleaf service. So that's not good. In general, we got back the HTTP status code 500, so that's consistent with what we have seen in the UI. OK, fair enough. So just to confirm, let me click here. I can see, indeed, the water service is fine. I don't see any errors. We went to the database in no time and got back some results. Fair enough. So water service seems fine. I will double check that the result set, because here you can see the water service is connecting to the water database. So there was a SQL query happening here that we wanted to get back some values for water size medium. And the result set is JDBC row count equals 1. OK, so there was a result. So no problems here in the water service. What about the tleaf service? So the T service is calling the tleaf service. There's an error here. We can already see it. So it returned 404. OK. Now we have the connection from the tleaf service to the test database. So the query we're doing is we want to retrieve some information for English breakfast. Great. OK, it's here. Now, what is in the result set? Oh, JDBC row count 0. OK. So that means that most likely we tried to retrieve certain information for a tea with tleaf's English breakfast, but they are not there in the database. So the question is, was it just me? Maybe I was unlucky. Maybe I stepped on some cable and the database didn't find the result. Let us see if this particular problem, English breakfast, is it a single thing or is it more common? So to do that, I can go to Loki, which is the last app that is used for querying the logs. So it can aggregate the logs and you can query them. So what I'm going to say is I'm going to pick the app T-service, and I will say, find me the severity or the level of logs for error, and show me only the lines that have the English breakfast in it. Thanks. English breakfast. There you go. So there's quite a few of those, although I have no idea why they are not here. But we have it also here. So that means that it's not a single case. There were more than a single scenario of those English breakfast problems. So apparently, it seems that we're missing something in the database, right? So how about we try to fix it? So let's go to our app, tleaf service. Since we are versioning our schema, and we're using Flyway, let us go and see what we have here. So we have version 1, create tleaf table. We have inserting of the resources. What do we have here? We have Sencha, Gyurko, Dachung, Pao. OK. But where is the English breakfast? So we're missing this. So there is something in the UI that we don't have on the database side. So that's highly unfortunate. So let's try to fix this. And we're going to add a version 2, which will insert the English breakfast. So there's some identifier, the English breakfast name, suggested amount 4 grams, 4 minutes of steeping time, 85 degrees of water, and type black. Apparently, Jonathan told me that these values are wrong, but let's ignore this. So what I will do right now, since we're using Eureka, I can run a second instance of the tleaf service on a different port, right? So what will happen is that when the app is starting, it will upgrade the schema. So hopefully, we will stop seeing any exceptions whatsoever. Why? Because both instances will use the same database, but one of the instances will upgrade it to the proper version. So let's see if that's going to happen. OK, stuff is going on. Let's now search for English breakfast. Yeah, migrating schema public to version 1.2. There you go. There you go. Duct taping on production. So migrating schema public to version 1.2, insert English breakfast. So we've managed to upgrade the schema for both the applications because they are sharing the same database. So now, if I run this query, again, we're not seeing any new spikes here, although I have no idea why we're not seeing any here, but maybe we're just unlucky. Maybe the users are not clicking the English breakfast. But let's double check in a dedicated dashboard whether the number of errors has fallen down. So here we have a dedicated dashboard for our T API. So here we have a T service latency. Here we can see the max, the 99th percentile, and the 95th percentile. Here we have the throughput. So it shows success rate and server error rate. So here we have right now, we used to have some server errors because they were above 0. And now we have only successes and 0 server errors, which is great, which is fabulous. I will run one thing. Just completely ignore me. Let's come back here. I will explain one more thing over here. So we have this heat map, latency heat map. So that shows that for given colors, for example, the more red it is, the number of requests for this given bucket is greater. So that shows that the overall latency is between, let's say, 8 and 40, right? So let's say we've managed to fix the problem with the exceptions. There's nothing going wrong with that. So most likely I can go home. My work is done. There's going to be another shift coming in that's going to take care of the support, unless somebody sees any new problems right now. What is the problem? Latency? Oh, that's quite unfortunate. So as usual, the moment I said everything is fine, something had to pop up. So what we see here is that we used to have latency around like max was 33. Here we have a little bit more because I started to run the second instance and it took a while. But now we have around 200, which is ridiculous. Maybe the dashboard is broken. Let's take a look at the heat map. OK, but the heat map is not broken. It shows that there's a lot of requests being in the buckets of like 220 milliseconds to like 250. So that's really, really bad, right? So any ideas what could have happened in the meantime? We don't know, right? Let's try to check it out. So let's try to double check whether indeed, let's confirm that the latency latency on the HTTP side is actually bad. So we can pick a dedicated Spring Boot dashboard, for example, and let's pick the edge service, which is the T service. Now, we're seeing latency. So latency can occur due to a number of reasons. I'm running everything. My production system is running on my machine, on my laptop. That's the usual thing that we're doing. So maybe I started to defragment my drive, or I don't know, started running some heavy CPU-intensive processes in the background. And this is why. So let's check it out. So heap usage is normal. No more open files than the usual. CPU usage, system CPU usage is flat. Load average, like everything is absolutely fine in terms of basic statistics. So let's put them down. JVM statistics, everything seems super flat. Nothing special is going on. Okay, so that's not this. GC, okay, nothing special. Hikari, so the data source. T-service doesn't have a database, so let's skip it. HTTP statistics. Okay, this doesn't sound good, right? Indeed, when we were sending the request to the edge service, we started seeing a spike in the latency. But that's expected because this is the edge service. So most likely some other service is being the culprit. So let's close the Tomcat statistics and logback statistics. Now let's check the water service. So the water service, the database. OK, flat connection creation time going down with usage time, going down with acquired time, and these are like microseconds, so that doesn't make any sense. HTTP statistics, latency is super small, so it can't be the water service. It can't be the water service, or it's highly unlikely that this is the water service. Let's check the T-leaf service. So connection usage time is going up. It's still quite small. Acquired time is going up. And the response times are big, very big. So let's go to the dedicated dashboard that we have specific for the database, because I have a hunch that this is related to the database. So let's open the Spring Boot Hikari JDBC dashboard. Let's go to the T-leaf service. And aha, there we have it. So we had around 2 milliseconds of usage time. Now we have 100 milliseconds. So we have seen latency around, what was it, 200 milliseconds? So most likely, we have around 100 milliseconds of latency on the database. So when we acquire the connection, we run the query, 200 milliseconds. I guess. This is my hunch. So what can we do now? Let's go back to our dedicated dashboard. If we check the T-service latency, let me make it a little bit bigger, and let me stop the refreshing. You can see small, I think these are triangles. These are called exemplars. So what is an exemplar? Whenever we are catching metrics, we will try to see if there is a corresponding trace ID, this correlation identifier. If there was a running trace ID, if there was one, we will pick one and attach it to the metrics. Why does it make any sense? Because maybe, or I will ask you a question, who has heard of the 3 pillars of observability? Okay, there's a couple of people. So in general, people say that there's like logs, tracing, and metrics. But saying that these are pillars is not a good idea. I mean, maybe it's semantics, but you shouldn't be looking at them separately. You should always look at them together. This is why today we've managed to go from, for example, tracing to logs, from logs to tracing. Now what we can do is we can go from metrics to tracing. Because what we will do is we will pick one of those exemplars over here. There you go. So we will pick one of those exemplars before the latency spike. We'll click it here, query with tempo. So in the new window, we have the trace view for the processing of the request before the latency spike. And now let's check one after. But I'm going to just copy the trace ID, and we will split the view into 2, like this. And let's refresh this. OK. So I can now, side by side, view 2 situations that occurred in our system. One before the latency spike and one after. So let's check what we have here. Let's look at the numbers first. Okay. So here we can see that it took us 8 milliseconds, because we said we have a hunch that something is wrong with the database, right? In tleaf service. So here we can see that it took around 8 milliseconds before, and after the latency spike, it took 200. Fair enough. We confirmed that with the HTTP metrics. Now, as far as the database side is concerned, here we can see that the connection took 200 milliseconds, whereas earlier it took 4 milliseconds. So we have 200 milliseconds for the connection, within which 100 milliseconds took doing the query. So what we've managed to do right now is to dissect the problem using distributed tracing and exemplars to capture those things together and narrow down the problem, most likely to the database. So what we can do right now is try to, we would do two things. One is immediately call the DB admin saying, help, there's something wrong with the database. But we can't really do it and go home. We need to save the day. We need to help our customers brew tea. So what we will do is we will try to quickly introduce caching, because we know that in the database we have just 4 entries. So that's not bad. It should cache fairly quickly. And that way, the latency should drop. So what we will do right now is we will go back to our code. And since we're working in the cloud, normally what we would be doing is we would introduce caching, restart one of the apps, or even run a new app under the same name, deregister from service registry both existing apps, wait for the client caches to clear, and only then stop the apps. But I don't have time for this, so I'm going to be butchering those apps and just going to kill them and restart them. So what we will do is we will enable caching. There we go. And on the repo, we will do cacheable tleafs. So I will rerun one of my apps. Come on, come on. There we go, it's being ran. Now, this looks really bad, but we'll manage. Kill, -9. And we will rerun the second app. Don't do it at home. That's wrong. It's a demo situation. Okay, so it will take some time for the caches to pop up, etc. What we will do right now is we will double check if we could have done something before, so that I'm not notified on my phone by the users that, hey, what is going on? But the metrics themselves will tell us that something is going on. And this is where we could use certain alerting mechanisms. So how could we do it? Let's go back to our dashboard. Over here, we have this throughput, right? So we have 2 cases. One is the server error, one is success. So what we could do is create an alert. And we could do it like this, that we would say, hey, give me the HTTP server request seconds count, a rate, sum it, and give me them for an exception that is not equal to none. So I want only the problematic cases. So these are the server errors. And now I could say, if the rate is above 0, so we have any increasing number of errors, exceptions, send me an email, like ping me on Slack, whatever. But then you can say, 0, that's a good number, but we have certain exceptions that are kind of okay. They have been there for the last 20 years, and internal server is not always bad. So we should skip some, and that's fine. That's fine. Why? Because if you have metrics, you have historical data, and you know that, for example, in your company, 0.2, if we have above 0.2 of the rate, then something is really wrong. So this is why metrics are really, really great. Now, the second thing I wanted to show you is that Most likely, we have managed to fix this problem with the database. I mean, not the problem, but the apps. But in our case, the latency happened on the database, in the database itself. But what if it turned out that the connection times were fine, but still there is latency? One of the reasons could be queries. So this is why in Spring Boot, together with Spring Data, what we have is we are providing certain metrics for you. So here we have Spring Data, repository invocation seconds count, for instance. Let's pick it for application tleaf service. And let's do a rate. Okay. And now what you can see, let's pick the last 5 minutes, is that we used to have some rate at which, let's say, those queries were called, right? And now they dropped to 0. Is it a good thing or a bad thing? What happened? Why do we have 0? What the rate at which the, let's say, time related to execution of all the tleaf service repositories went to 0. So they are not called. So what happened? Caching. So we've managed to finally cache it. So let's check the graph again, the TAPI. And we can see that the latency has dropped to the values that we had previously have. Here you can see the small spike in success and spike in errors because I reran the apps manually without deregistering them, etc. But we have finally managed to go back with the latency. You can see that we're back in the buckets from around 5 milliseconds to around 40 milliseconds. So to sum up this part, what we've managed to do with the latency analysis is that we managed to confirm with metrics that there is indeed a problem with the latency. We've managed to use exemplars to map metrics to traces. We've managed to analyze the traces to double-check that the problem lays with the database, and we've managed to fix it. So 3 pillars of observability: logs, traces, and metrics. We believe that they should be always intersecting. These are more like areas that are, intersecting. And the ultimate thing you could do is you could have a dashboard that has all the 3 things together. So you can reason about things together. So let's say that we're going to pick the last 15 minutes. Let me pick one of the traces that is there. OK, I'm unlucky. Unlucky. So to the top, you can see that I've picked one of the trace IDs, so one of those correlation identifiers. And I've asked Loki to give me all the logs from all the applications that correspond to this particular trace identifier. And they are put in a chronological order, which means that I can look at the logs from the beginning until the end and analyze what's going on. I can then have the same trace ID put in a tempo dashboard to view the latency in our system. And last but not least, here I have latency, but I could have other metrics that are put within the same window of time. And now I can look at those 3 dimensions properly in order to analyze the potential reasons for a given problem. Okay, so that was the demo. I have no idea why it worked, but it worked fine. So now let's try to do some sort of a summary. How does it work? Because I showed you how to use it, how it effectively works, but how does it work internally? So let's talk about metrics. By the way, I would just mention it again. Everything I'm showing you is, let's look at this in a high level. At a high level, right now I'm going to be showing some concrete examples like libraries, but the topic is absolutely generic. So in our case, we're using metrics with micrometer. And it works like this, that let's say we have those 4 services. All of them are Spring Boot applications. They have micrometer on the class path. So micrometer with boot know how to do various things, like measuring latency, for example, like if Prometheus is on the class path, we know how to create an endpoint that, let's say, presents the metrics in a Prometheus format. Then, in case of Prometheus, you need a polling mechanism, or you have to configure Prometheus in such a way that it polls for metrics. accesses our apps and polls for the metrics. And then you can visualize the metrics. Here you have tons of observability by Wavefront UI, but it doesn't really matter. Like, pick a tool of your choosing. Metrics are easy. What about log correlation? How does this work? You need some sort of a library that will give you the distributed tracing context injection into the logs and propagation over the wire. So what you can use is, for example, Spring Cloud Sleuth or the new micrometer tracing library. So how does it work? Let's say a request comes in, an identifier, the trace ID is set. Let's say it's 1 to 3, right? So what happens is that throughout the life cycle of processing of this request or subsequent request for this particular business operation, the identifier will be always attached to the logs. So here you can see 1 to 3 and some logging statement. Now, the framework then needs to propagate this information over the wire to another service. So when this service is logging, we will attach the identifier to the logs. And the same thing for service 3 and service 4. So whenever each of those services is logging, always we're going to have the same trace ID. That way you can afterwards say, give me all the logs from all the apps that have the particular trace ID. Then when you have the logs, you can ship them to a log store. In our case, that was Loki. And then you can visualize all the logs from all the apps with a given trace identifier. So what about distributed tracing? How does that work? You can use Spring Cloud Sleuth and micrometer tracing. We have those 4 apps. Let us assume that service 1 is calling service 2, 2 is calling 3 and 4. So here we have a certain observation that is interesting, right? What's the latency here? We might be more interested in having a more granular measurement, maybe when the controller is calling the service. We could ask ourselves this question and maybe introduce an additional observation over here. For sure, these 2 calls should be observed, right? So we have those observations. So in the world of distributed tracing, we don't say actually observations, we say spans, right? So we would need a library, for example, Spring Cloud Sleuth or micrometer tracing, that would create a span, start measuring time, and instrument, for example, your HTTP client, that the headers of the request will contain certain standard information that the service 2, when it receives the request, it will know how to continue, right? Because we need to propagate the information. So on the client side, we need instrumentation. On the server side, we need instrumentation. If service 2, for example, from the controller, for some reason, spawns a new thread to do processing in application service, you need the framework to propagate the tracing information to the new thread. If you're using RX or whatever tool of your choosing, same thing. Dedicated HTTP clients, you need to instrument them. So nothing comes like for free, something has to do it. And then you have, let's say, the same thing, so spans when calling from service 2 to service 3 and from service 2 to service 4. So why are we doing this? Because that way we can build the parent-child relationship. So the trace ID was 1 to 3, and so that we knew from the log correlation part. Now a span is being created. When service 1 is calling service 2, we're going to create a child span, because this is a new operation that we want to measure. So so span 2, 3, 4 has the parent with ID 1 to 3. Now when service 2 is calling service 3, then a new span is being created with ID 3, 4, 5, whose parent is 2, 3, 4, etc., right? If we treat those operations as certain objects that have certain characteristics, we can then define that the given span has a parent with a given ID. Has certain start time, has certain stop time, so the duration, and metadata. Metadata being the tags, like, for example, JDBC row count or HTTP path, right? So what you've seen previously in the tracing visualization tool, this is the metadata. So what can we do then with the span? We can push it to a span store that can later visualize the whole thing. Here you can see a screenshot from VMware tons of observability by Wavefront. Here you can see the production dependency graph. All the tools for tracing analysis can do it, that you can, from production, build the graph of, let's say, dependencies between your apps, like who is calling who, how often, and how many errors are there, for example. So here we can see from production that the shop UI is calling cart and catalog, and cart is calling the cart DB, and catalog is calling catalog DB. And to the bottom, you can see the whole trace, which means that it took 1.3 of a second to process the whole thing. And one of the spans, one of the operations being the select on the catalog DB took 1 second, which is a terrible result. Now we can reason why. So what options are out there? So there are certain tracing standards. We have OpenZipkin, OpenTracing, OpenCensus, and OpenTelemetry. So what do they have all in common? They are open, which is a lie, dear friends, because OpenTracing and OpenCensus are closed. They're gone. Nobody uses them. It's deprecated. Goodbye. So we have OpenZipkin and OpenTelemetry, and let's talk about them. So what is OpenZipkin? It's in fact a server, but it's also some ecosystem of projects. It's also a standard of tracing propagation. In general, it's a mature ecosystem, production tested, and has multi-language support. So Zipkin, I know that stars on GitHub is maybe not the best rating system, but it at least gives us something. So Zipkin has around 16,000 stars on GitHub, and first release happened in May 2016. Brave, which is a tracer library. So what is a tracer? It's a library that handles creation, stopping of spans, instrumentation, etc. Right? So all the, let's say, logic that happens under the hood, you need a library for that. So Brave is such a library that has around 2,200 stars, and the first release happened in April 2013. And OpenZipkin has quite a few supported languages. Now, OpenTelemetry, OTel, because OpenTracing is OT, so they had to do something new, OTel. It's new, has support for multiple languages, and is CNCF oriented, so Cloud Native Computing Foundation oriented. Now, OpenTelemetry Java has 1,200 stars on GitHub, first release in November 2019. Any milestone, I'm talking about first milestone. OpenTelemetry specification has 2,600 stars, the first release being in June 2019. First GAs happened in 2020 and beginning of 2021. And now there's one thing to talk about GAs for OpenTelemetry, because they said that the spec is GA, but for example, the HTTP metrics, sorry, the HTTP tags specification is experimental, which means that it can change at any time. They can break the compatibility even though the spec is GA. So you have to take care of that. Also, OpenTelemetry Java is GA, but not Java instrumentation. So you can have a tracer, but you will not instrument anything because Java instrumentation is not GA yet. And also, OTel addresses logs, tracing, and metrics in general. When we're talking about GA, GA-ish, I guess, we're talking only about tracing. The rest is not GA. I think metrics maybe are recently GA, but it's a very, very fresh thing. So be careful. Read carefully about what you're using. Plus, correct me if I'm wrong, but from what I heard from some people going to the OpenTelemetry meetings, they do not treat changing the metric name as a breaking change, which is very strange. For sure, in micrometer world, we will be treating renaming something as a breaking change, right? Because imagine you have dashboards, and suddenly all your dashboards are broken because the metric has changed. So they have quite a few supported languages as well. So let's look at certain latency visualization tools as some examples. VMware Tons Observability by Wavefront. If you use it, it's free for Spring Boot applications. You don't need to sign up. We have OpenZipkin, and we have Jaeger, which was let's say heavily influenced by OpenZipkin, to say the least. And we have Grafana Tempo that you have seen today. Now, metrics visualization, again, these are just examples. There are like a lot of other tools that I'm not presenting here. So VMware Tons Observability by Wavefront, and today we have seen Grafana. What about logs visualization? The infamous ELK stack, Elasticsearch Logs / Kibana. And today you have seen Loki. So last but not least, I would like to say a few words about Micrometer 110 and what we're working on there, because I mentioned that, for example, OTEL is using 3 different APIs to work with logs, tracing, and metrics. Now, we think in Micrometer team that we can have 1 API instead of 3 to solve this problem. So how we see it, of course, it's a subject to change because it's still in milestones. But in general, you have certain observation registry. You have certain context that is mutable. You can put some stuff there. And then you want to observe something, right? So you create an observation, and then you observe something. If you want to observe something, what you want there to happen is, for example, you want metrics, tracing, logging, or something else that we haven't yet thought of. Because, like, if there's something else in the future, maybe there's going to be a need for the 4th and 5th API, right? We don't want this. So what we believe in is some sort of a plug-in mechanism. So handler mechanism, where you can react to an observation starting, there being an error, stopping, etc. And then if you have a plugin mechanism, then we can, for example, provide you with a metric handler that whenever an observation happens, we're going to measure the time, and then you can use Prometheus or Tanz observability to view the metrics. Maybe you can use our tracing handlers. Then, out of the box, either via Brave or OpenTelemetry tracers, you'll be able to ship your traces to Zipkin or whatever else, right? And for logs, we haven't provided anything out of the box because we have no idea what you want to log. But you can create your own handler that whenever you are observing something, you can you can log something out, and then you can push those logs to the tool of your choosing. So that's it from my side. Hopefully that was interesting. So time for questions. We have 4 minutes. Here's my Twitter handle if you want to ask me questions later on, and I guess it's time for questions. Any questions? Going once? Yeah, there you go. The question is, what was the problem with the database? The problem with the database is that I'm using something called a Toxi proxy. Let me find. OK, I will not find the configuration right now. So I have a whole setup running in Docker. I'm using Docker Compose. And the tleaf service application is not calling my Postgres database directly. It's calling it via Toxi proxy. And I have manually introduced 100 milliseconds of latency. When I said, hey, I need to run a script, that was me adding 100 milliseconds of latency. But that's a great question. Any more questions? No questions. OK, so thank you very much. Oh, there's a question.
Do you share your demo repo to see all to download it and check it?
The question is if I'm going to share the GitHub repo. It's already public. I'm going to share the link to the repo. That's not a problem. Any more questions? Going once, twice. OK, thank you so much. Enjoy the rest of your conference.